Hi, this is Fazana again. Welcome to part 2 of this topic. As mentioned in part 1, shapes are similar if the angles are the same and the length of the sides are in proportion to each other. Where you have two circles or two squares, of course, they will always be similar. One will always be an enlargement of the other. And remember, this is not the same as another tricky maths word, congruent. Two shapes are congruent if they're exactly the same sides, same angles, same everything. Okay, let's do some questions. Okay, triangle ABC is similar to triangle ADE, and it gives you the lengths, and it says work out the length of DE. What I normally do is give the two shapes their own space. Okay, so you can tell the whole length of that triangle there is 21 centimeters. Okay, and let's go label this one. So that's A, B, C, and that one's 15 centimeters, and that's 12.5 centimeters. Okay, so we've got two common sides. So the first thing we do is find the scale factor of the length, which is 21 divided by 15. They can both be divided by 3, so 7 divided by 5, which is 1 2/5. And for calculation purposes, we'll just make it into a decimal. Yeah, all right. Okay, so if we have to find the length of DE, then we're going from smaller to bigger. So we take the 12.5 and we multiply it by the scale factor of the length. So it will be 17.5 centimeters. Okay, that's easy as that. Okay, let's do another question. A 20 euro note is a rectangle with those dimensions, and a 500 euro note is a rectangle with those dimensions. And show that the two rectangles are not mathematically similar. So we know that the lengths and the widths have to be in proportion. So what I do is I say, that's the bigger one. So I say, is 165 divided by the 133, that should be the same fraction or proportion as the 82 divided by the 72. Yeah, so the lengths have to be in proportion to the widths. So here I get 1.241, and when I divide 82 by 72, I get 1.139. And because those are not equal, yeah, you say not in proportion, so not similar. Okay, as easy as that. Next question. Okay, in the triangle below, RT is parallel to HS. So again, they're mathematically similar. And we've got an X there. How fun is that? Okay, gave it its own space. So that will be the M, that will be the T, and that will be the R. And that will be 4. Okay. What else right now? Okay, and that of course is the 10. And that's the X, sorry. Yeah, all right. Do we have two similar corresponding sides? Yes. So the scale factor of the length is 10 over 4, which is 5 over 2. Okay, and in order to find out X, you can tell that if we multiply x by 5 over 2, then we should get the 15 plus x. Yeah? So if we go 5 over 2x, so we'll just put the 5 there, equals 15 plus x. Alright, okay, so we use the Faz format of 6 divided by 3 equals 2. So we can cross multiply. So we've got 5x equals, and each of these has to be multiplied by 2. So you've got 2 times 15 is 30 plus 2x. Okay, and then just normal linear equations. Minus 2x, so you've got 3x equals 30, and divided by 3 to get 1x. So x equals 30 divided by 3 equals 10. Okay, so you can see 10, and that would be 10 there, which would make that whole length 25. Okay, and we can just check it, because we know the scale factor of the length should be 5 over 2. So 25 divided by 10, and if you divide them both by 5, you get 5 over 2, yeah? Which is what the scale factor was. Alright, okay, cool. So don't let a letter scare you. Alright, next question. Okay, now they just bring in an odd shape, just to confuse you again. Alright, so we're going to first find the scale factor. So what do we have in common? Again, you can tell that's drawn a bit tilted, so I've given its own space again, or drawn it so that it looks easier. So you've got x, y, z, and v. Yeah? And that's your W there. Okay, all right, what do we know? That's 3 there, that's 2 there, that's 6 there, and anything else right now? Okay, so you can tell we've got 2 similar sides, corresponding sides here. So the scale factor is 4 over 3. And again, we will assume non-calculator so that it's easier to play with. So if we want to find ED, you can tell we've got the 6 and we're going from smaller to bigger. So we're going 6 times 4 over 3. We cross divide. So you have 2 there. So 2 times 4 is 8. Yeah, all right. VZ. So VZ is there. So we've got the 4 there. So now we're going to go 4 divided by 4 over 3, which is the same as saying 4 times 3/4. So we go opposite, opposite. And when we cross divide, we just get left with 3. Yeah, okay. And you can tell that must have been 3 because that was 4 and 3, so that must be 4 and 3. Okay, CB, so that bit there. So we've got the smaller length of 2. So we're going 2 times 4 over 3. And we cross multiply, we multiply straight across. So you've got 8 over 3, which is 2 2/3. All right. VW, which is that. So we've got the 5, and we're going from bigger to smaller. So we're actually going to go 5 times 3 over 4, and we get 15 over 4, which works out to be 3 3/4. Okay, and then they're asking you to find angle Z, and you can tell because they're similar, that does nothing to the size of the angles, so that is still 84. Yeah, and of course that one will be 30. So you can see the angles stay exactly the same. All right, okay. Nice 5-6 marks there. All right. Okay, two plasma screen TVs are similar rectangles. Their scale factor is 8:5, so I'll just write that there. The perimeter of the smaller TV is 70 inches. Okay, so you know when you add all four sides. The lengths of the sides of the larger TV are represented by x's. And what is the value of x? Okay, the way I teach year 6 kids is I say if the perimeter is 70, then you know that side will be the same as that side will be the same as that side. So you just add that one, and then multiply by 2. Yeah? So you can tell that if the perimeter is 70, then that side there and that side there have to be equal to 35 inches. Yeah? So that's in terms of dimensions. We'll say 35 has to be the dimension of those two. Okay? So because it's in proportion, it's been multiplied by 7, so we'll multiply that by 7, and that gives you 56. So can you see 56 has to be the total of these two? So then we've got 3x minus 4 plus 2x is equal to 56. 3x plus 2x is 5x, minus 4 equals 56. I love these linear equations, it's just so soothing. Plus 4, 55x equals 60, divided by 5, x equals 12. Yeah, alright. Okay, so when they asked you for the value of x, we got it. Alright, cool. Okay, last question. Okay, in the diagram, BC is parallel to DE. Okay, if they're parallel, anytime you get parallel lines, just extend it a bit. And you can tell that you'd get your F's. So that angle there would be equal to that angle there. That angle there would be equal to that angle there. That's a shared angle. So of course you can tell that's what makes it similar. Yeah, all right. Okay, gave it its own space. So we've got ADE, and that's 5.8, and that's 4. Okay, so again, corresponding sides. So our scale factor is 12 divided by 4 equals 3. All right. Okay, so prove the triangle ABC similar to triangle ADE. So that's what you talk about. Those angles are the same, those angles are the same because they're corresponding. So you've got your F's, yeah? And that one is a shared side. All right. Okay, then they ask you to find the length of AC. So AC would be that whole side there. So we've got the corresponding one of 5.8 there. So all we do is go 5.8 times 3, and we get 17.4 centimeters. All right, cool. Okay, find the ratio of the area of the quadrilateral DBCE to the area of the triangle ABC. Okay, so you can tell we're not doing it to the smaller one, to the bigger one. We're actually finding, we're taking that one away. Okay, all right, now let's get serious. If the scale factor of the length is 3, then the scale factor of the area is 3 squared. And I'll just sort of demonstrate that to you. If you had a square of 2 by 2, and you've got, so the area would be 4. If you had a scale factor of 3, and then you've got 6 and 6, you've actually got 36. So you can tell 36 divided by 4 would be 9, which is the 3 squared, because you're taking a length with a scale factor of 3 and multiplying it by a length of scale factor 3. So then your scale factor of your area would actually be your scale factor of the length squared. Yeah? Okay? So you can tell the area of the big one is 9 times as much. So if you had ADE to A, B, C, then you can tell if the area of ADE was 1, then the area of ABC would be 9. Yeah? So what's left? So that's the 1, that's the 9. So that bit there would be the 9 minus 1, which is the 8. Yeah? So if we put that there, DBCE would be 8. Yeah? So that would be the ratio. So the area of DBCE to the area of triangle ABC, the ratio would be 8 to 9. Okay? So be really careful of the words, because when you're doing the question, you just wrongly assume that they're going to ask you for the ratio of that area to that area, yeah, rather than the bit that would be left, yeah, if that one was removed. Okay, so be really careful. Every single word in your question is important, and you do so many questions that are similar, and then you get them in your exam and you just assume that it's exactly the same. Well, that's how they trick you, that's how they hide it. So you've got to be not just clever, but very sharp. All right? Okay, that's all for now. I hope that was helpful and easy to understand and fun. Now, please watch the Fazmaths videos on similar shapes, where we talk about scale factor of the length, the area, and the volume, where we learn how to calculate the areas and volume of similar shapes. And keep working hard, practice, 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 and remember, you're in control. Take care. Until next time. Bye.